Moving into lesson 5.2, part 2 today, where we are multiplying and dividing radicals. So in 5.1 and in 5.2, part 1, it was more about how do we convert between the radicals, so the square root symbols, and the rational exponents, the fraction exponents. So what's the relationship there? We're going to take a little bit of a break. We're not going to work with the rational exponents as much. We're going to work more with the radicals, the square root symbols. How do we multiply and divide when we have these radicals or square root symbols? Okay, so you've got two basic properties up top. We've got the product property, which what I want you to look at is right here. And that's just basically saying that you can multiply radicals as long as the index is the same. So you can multiply a square root times a square root. You can multiply a cube root times a cube root. Fourth root times a fourth root. What you can't do is you can't multiply a square root times a cube root. Okay? Division is the same in that you can divide as long as the indexes are the same. So as long as we're talking the same type of root, we can divide those. Okay? So that's the key you'll have to watch for as we multiply and divide. Now, before we multiply and divide, we want to get into a little simplifying here. Okay? And what we're going to work on in this first section is just being able to simplify radicals. Because if you know how to simplify radicals, multiplying and dividing works out a little bit better for you. So as we look at A, rewrite each expression using properties of exponents. Basically, this is not in simplified form right now. We want to talk about how to get it in simplified form.
Wait a minute.
Okay? One of the first things, so square root of 54x to the fifth. One of the first things I'll always check is 54 a perfect square?
No. It's 3
No.
to 6. Square root of 6.
Okay. Okay, so your calculator will not be allowed on the test.
What? That's all you gotta do, just put it in.
Yeah, your calculator's not allowed on the test because that's why I'm testing this chapter.
So you got the answer.
Yeah, you got the final answer.
That's the answer?
Yeah.
Any calculator can do that.
Nope.
Wait, what did you get?
I put square root of 54.
Did you?
What do most of the rest of you get for square root of 54?
7.34. Wait, what did
So you got a big, long, messy decimal, right?
What do you get?
3 square root of 6.
What would you get it? Or when?
I have one of those. 7.34.
Okay.
Where's that square root?
So here's what I'm going to tell you. If your calculator has the capability of telling you 3 square root of 6, now listen. If your calculator has the capability of telling you 3 square root of 6, you will not be allowed to use that on any official quiz or test in topic 5. Okay, because, and I know you're going to tell me I can turn it off, but you can also turn it back on, and I'm not going to stand over your shoulder and supervise during a test. So, now you have is that the TI 36?
30XS.
30XS.
That's the 30XS
Okay.
model.
Most Texas Instruments will work. Okay, if you use the one like I use, it definitely will work. Casio, I don't know what setting yours is in, but the Casios, you can usually switch it back and forth. So Casios, I usually deny too. Now, here's the deal. I'm saying this right now on day 1 because, am I saying you can't use any calculator? No, I'm just saying Aaron can't use that calculator. Tate probably can't use the one that's in his locker. Okay? CJ's not going to be able to use that calculator in front of her, I think. With, you know.
Please
Now,
Why
in the meantime, if I'm telling you you're not going to be able to use your calculator, what do you need to learn how to do in the meantime?
use one of your.
You know how to use one of mine. Okay? And
Wow.
the most part, a lot of stuff is the same, but certain things are different, especially between Texas Instruments and Casio. So, and if you have a question about whether or not you'll be able to use your calculator, let me know. But here's the deal. I will walk around on quiz and test day and check. And if I see a calculator on my question, I'm going to pick it up and play with it. If I don't like it, you're going to have to switch in the middle of the test. So it's better to know now than to find out on test day that you have to switch calculators on the fly. Okay? So, now, I think usually it's about the only chapter I deny those calculators. But I have to because that's what we're teaching.
What?
Now, in the meantime, those of you with those calculators have a slight advantage on homework if you use it in the right way. Now, if you just put that in and then write down the answer in homework, that's not helping you. But it can help you check as you're learning. Okay? Now, okay, so square root of 54. You guys got 7 point something, right?
Yes.
I don't want a big, long, messy decimal. But I don't want to round the decimal either. Okay? If this does not come out an exact whole number, we need to decide, can this simplify? And this is where we ask ourselves, are there any perfect squares within 54?
Yes, there.
So are there any numbers that you can take a square root of that divide into 54?
Well, 9.
Okay? Why is 9 important?
Because 3. Well, yeah.
Okay?
Well,
9 is a
I know, but then-
perfect square, yes. And 54 divides by 9. Now, if you're saying, yeah, I didn't get that. Well, this is where you need to, and actually I'll pass it out here in a moment, but my recommendation is you just start dividing by the perfect squares so you find something that works. Okay, this one was a more obvious one, so what I'm going to do here, I'm going to break this up. 54, actually, let's see, let's do 54 breaks up into square root of 9 times square root of 6, yes? Square root of 9 times square root of 6 is still square root of 54. I'm doing that because I can take the square root of 9. Now, we have a variable to talk about too. Square root of x to the 5th. Can you take the square root of x to the 5th?
Why not? Absolutely.
So let's go back and ask, how do we take the square root of an exponent?
That is a great question.
Okay. What's the index of a square root? A square root is root 2, yes?
Yeah.
If you think about back to exponents last week, how did we take a square root? We took the exponent and
The denominator.
divided by 2, right? So the idea here, you take 5, you make the denominator 2, but does 5 divide by 2?
No.
No. So we're going to have to, kind of like we broke 54 up, we're breaking up x to the 5th. Here's what I want to know. Okay, 5 does not divide by 2, correct? Closest number below 5 that divides by 2.
4.
4. So I'm going to break this up into x to the 4th. And what's the leftover piece? X to the 1st. I'm breaking that up into the biggest number under 5 that can divide by 2, which is 4. And then that 1 is just the leftover. Okay. Now we're ready to finish this problem up. What is the square root of 9? 3. And I'm going to rewrite this in a different order when we get done, but what is the square root of 6?
Or in one.
It's some big messy decimal,
You break that one up too.
okay? Can it break up? And here's what I'm going to say. So Gatlin says, do we break that one up too? My response is, if it can break up, yes. But the only thing that 6 divides by is 2 times 3, or 2 or 3 perfect squares. No. So square root of 6 is going to stay square root of 6. Aaron's calculator in this one is either going to tell him square root of 6 or it's going to go to decimal form.
Yeah.
It's not going to give me an answer like it did earlier. Now, square root of x to the 4th.
X squared.
Okay, x squared, because what can happen? We can do 4 divide by 2, right? And so that's going to be x squared. What about square root of x to the 1st? It's going to stay square root of x, yes? Because does 1 divide by 2? Not evenly. So that's going to stay square root of x. Now, when you write this as a final answer, I would put all the pieces we took out of radicals out front and combine the pieces under radicals. So out front, I'm going to have 3 times x squared. What remains under the radical? 6 times x.
Yep.
Okay. Now, what did Aaron tell me the square root of 54 was the very first, right off the bat?
3x.
3 squared S.
3 square root of 6. Now, his calculator's not going to do the variables, but right there, here's the math to get to his calculator's answer.
You got an old that I can use?
A what?
Another one that I could practice with while I'm
Yes.
doing notes?
And that's, the calculator's always up here. Again, I'm not going to say, oh, you can't, you have to provide your own calculator now. If you have a calculator but I'm banning it, by all means, practice with one of mine. Okay? And so, and I will say, what did yours give you when you did yours? Did it give you the
Don't
decimal
lie,
right now?
CJ.
Okay, so like CJ's is giving you the decimal right now. I don't know if she knows how to get over to the other form, and she's giving me this look like I don't. But if I recall correctly, oh, this is caliber, this isn't Casio.
The Gatlin has one of those.
But I'm 99% sure, and I'll look later, that I'm probably gonna ban CJ's calculator. Okay, so like if you have a Casio that looks like this, the Casios most of the time I end up banning too. If you have the, what I use,
A TI 30X.
TI-30X2S, this one actually has a B. I didn't realize I had a B in there, but these are definitely good. Okay, the TI-84 Plus, the graphing calculators, those are good.
Just one.
If you have questions, ask me individually, right? Okay. So B,
Let me take a stab.
square root of 128. Now, one thing I will always check, is square root of 128 a perfect square?
No.
Okay, is your calculator giving you a yucky decimal? Okay, but we checked. Especially as you get bigger numbers you don't know. So now your job is what does square root of 20, or I shouldn't say what, but I'm going to assume there's something. What perfect square does square root of 128 divide by?
30. Okay.
All right, 32 and 4, 64.
16.
I'm getting lots of different answers.
Well, 34 and
You
32
know what? I
and 4
guess
is
this guy's right. 64 is the best one. 64 is good. We'll just go with it.
something.
Okay. Now, okay, I heard, Landon, what did you say first?
4 and
Yo.
Okay, okay, so I've heard 3 different options, I think, and we're gonna have to talk about what's best. So Landon started off, he said 4 and, what was it, 32?
I say he's good right then.
Okay, is 4 a perfect square?
Yeah.
Yes, the square root of 4 is 2. Now, Xander, did you say 16 and 8? Okay, is 16 a perfect square? Yes, the square root of 16 is 4. Now, sorry, Landon, Xander's is a little bit better because
Bigger number.
he used a little bit bigger perfect square. Now, Josh, you said
64 and 2.
64 and 2. Is 64 a perfect square?
It's 8.
64 is a perfect square. It's the square root is 8. Okay, the bigger the better here. The bigger perfect square you can find, the better off you'll be. Now, could I start with the smaller numbers and work my way there?
Yeah.
You can.
Totally.
Because here's what I'm going to tell you. If I start with 4 times 32 or 16 times 8, well, here's what I'm going to tell you. Landon, 32 has a perfect square in it. Now you got to find that one. Xander, 8 has a perfect square in it. Now you got to find that one. Okay? Josh's other number was 2. There's no perfect squares in there. Are you seeing where I'm going with this?
Why are you so
Now, I'm going to hand out a paper that I think can help you here.
Yes.
Some of you are going to say this paper is unnecessary, and you don't need it. Okay, don't use it. Whatever. Some of you are going to love this, because some of you are saying, oh my gosh, I can come up with Landon's 4. That was easy. Past that, I didn't think to try 64, you know.
He does.
So, I'm going to give you a paper that I'm going to kind of teach you how I suggest you use it. So for those of you that the perfect squares don't just automatically come into your head, this will help a little bit.
Oh, yeah.
Okay?
Technically, isn't there an infinite amount of these? The fifths?
Yeah, I just there's an infinite amount of all these. I just listed the first handful.
Alright, I guess.
Now, I will say, maybe I should have expanded the fourth and fifth list this year based on a new book, but
I think I got the answer.
You said
Okay.
that last time.
now, okay. Let me talk about how can this paper help me.
Get your answers you're gonna use
Okay.
or whatever.
When I start looking at 128, okay, first of all, realize these first two columns are perfect squares, right? Let's talk about what's on the paper, I guess. We've got perfect squares, then I have some perfect cubes, some perfect fourth roots, and some perfect fifths, okay?
Are we using this here?
We're only talking about square roots right now. We're only talking about square roots because we are in square roots, right? Now, with that said, is 128 on my list?
Nope.
No, 128 is not on my list. So that just means, like we already talked about, it's not a perfect square. What I would encourage you to do, some of you it's going to be easier, some of you you're going to have to play with the calculator a little bit more. But what I encourage you to do is, okay, start at the number right below 128, where 128 would be. So that first number,
121.
121. Does 128 divide by 121? No. And I think you guys knew that, but I'm just trying to make a point here. Then, the next number after 121, if I go down here,
100.
100. Does 128 divide by 100?
Mm-mm.
Not evenly. Then we're going to try 81. Does 128 divide by 81? Not evenly. Then I'm going to try 64. Does 128 divide by 64?
2.
It does, okay? And that's a way I can use to find the largest perfect square, okay? And that way I don't get stuck in the, oh, I found 4, but it wasn't the largest. I found 16, but it wasn't the largest. And again, if you find 4, okay, just realize now I've got to check 32. 32, I could say divides by 16 or divides by 4,
No, that's 2.
okay? Too much work, so go big the first time, right? Okay. And I do let you use these blue papers on the test.
Yes.
Okay? Okay, so 128. We decided the biggest perfect square was 64, and it's 64 times 2. I'm just writing under all one radical this time. Now, x to the 7th.
I got you.
Is x to the 7th a perfect square?
No.
No.
6 is. No, it's not.
No, it's not. It's 4.
I did 4 as
Square root x4, then a square root x3.
What? 1.
Go back to your initial thought, Aaron. Here's the deal.
What?
How do we take the square roots of exponents?
I said x4, then x3.
No, she said that was wrong.
the denominator.
Oh, did not. Oh, that's possible.
Okay, here's the deal. To take a square root of 64, you do a square root. But with exponents, it's not, if I say x to the 4th, I'm not taking the square root of that by square rooting 4. You take the square root of it by dividing by the root. The root is 2 here, yes?
Ooh.
What is the largest number below 7 that divides by 2?
6.
6.
Talk about.
And so that's why I want to make this, instead of, I don't want to go x4, x3, x6, and what's left over? x1.
X1. Who said that, Josh?
Okay? So, with exponents, don't look for perfect squares. Look for what can divide by, for square root 2. Okay. Square root of 64 is?
8.
8. That's going to go out front,
Square root 8.
no longer under my radical.
Oh,
Okay? What's the square root of 2?
You gotta leave
Square
it
root
in
2.
there.
Square root 2.
Okay? I can't do it. It stays under the radical.
Give it some space.
What's the square root of x to the 6th?
X.
3. You can. Yeah, you can.
What did we just talk about? In order to take the square root of an exponent, you divide by 2. And 6 divided by 2 is going to be x to the third. Since I was able to take the square root, I'm putting it out front. What's the square root of x to the first? I can't divide 1 by 2, so it stays under the radical. Okay?
That was throwing me off because of the other one. Yeah.
Okay. We starting to feel for it? Little?
I'm feeling
Okay. Now, before we jump into C, and we all do this wrong, because I was about ready to do this wrong myself. What's the big
Cube.
change you have to notice?
Cube.
We are moving from square root world to cube root world. So now, if you're looking at your blue paper, instead of looking at square roots, we're going to look at the cube root column.
Cube root right there.
Now, and I say, it's so easy to make a mistake here because if you're like me, your brain saw 16. Oh, the square root of 16 is
4.
4.
Oh.
But
it.
we're not in square root world.
We're a cube
So-
root world.
Can you take the cube root of 16?
No, you cannot.
No, your calculator is going to give you some lovely
That's fine.
decimal answer.
Tell you what we can do though.
Cube root of 16, 2.5198421.
Answer.
Not what I want.
2.1.
So-
Go ahead, this guy right here.
Cube roots,
Like the company.
16. What does it divide by from my list?
8. 8. I got the answer.
8?
Okay.
Okay, so
That's 8.
stay with me, please. Okay, so 16, I'm going to break up into 8 and 2.
Square root.
Because I can take the cube root of 8, and 2 is the leftover piece. Okay, x to the 5th. Can I take the cube root of x to the 5th? No, and why can I not take the cube root of x to the 5th?
Because you can't divide 5 by 3.
Okay, 5 does not divide by 3. Perfect.
Oh.
So, what's the biggest number, largest number below 5,
3.
that does divide by 3?
3.
3. So when I break this up, I'm going to have x to the third. And what's my leftover? X to the second. Because this time, we're using 3 for our perfect cube. And out of 5, we still have 2 left over. So notice, I still have the same number of x's. I've just rewritten them. Okay. Cube root of 8.
2.
2. So that's going to go out front. Cube root of 2.
Square radical.
Lever in the box.
Square root of 2 or cube root of 2.
Stays in the
Box down.
radical. Cube root of x to the third.
X.
Because 3 divides by 3.
Equals 2.
And you get x to the first. So that's going to go out front. Cube root of x squared. I can't do it because 2 does not divide by 3. So x squared stays
X squared.
under the radical.
Hey.
Okay. Now, one thing I forgot to mention. Did you guys figure out on my blue paper how this blue paper is set up?
Yes.
The cube roots. The cube root of 8 is what?
2.
2. Cube root of 27 is?
4, 8, 16, 32.
No. Cube root of 27 is? 3.
Top row.
Cube root of 64 is? 4. I'm counting down the page.
Wait, what?
Square root of 125 is?
5.
5. Square root of 216 is?
6.
6. 7. 8. 9. 10.
Wow.
If it's helpful to you, you can write those numbers on your list next to it. The fact that the top one is 2, and it goes all the way down to 10. I didn't bother to put 1 on there. The cube root of 1 is 1. Okay? What did I do in the square roots? Did I do the same thing?
Yeah.
Except I did 2 columns of them, right?
Right.
But square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. All the way down to 10 in the first column. What's the square root of 121? 11.
then it gets.
12,
20.
13, 14, all the way down to
20.
20. If you want to write those numbers next to them on your paper, you can. It's about the only thing I'll let you write on the paper and still use it. Take a wild guess on what the fourth roots. The fourth root of
4.
16 is going to be,
Four.
hold on. The
What?
fourth root of 16 is going to be
2.
2. Fourth root of 81,
3.
3. 4,
5.
5. What about the fifth roots?
2.
3, 4, 5.
2, 3, 4, 5. Okay? You can, if you run into a situation you need to expand that list, you can expand that list. Okay?
Yeah.
Okay. Ready for D?
I was born ready.
Okay. So D, we're moving into fourth root world. This is going to be the hardest part, is keeping track of the fact of what world you're in.
Like Rick and Morty.
Okay? We're in fourth root world here. Now, okay. Fourth root of 81. Can you do it?
Yeah, you
Let me look
can.
at that.
Great.
You can, can't you?
Booyah.
Okay. So that one, we're actually going to be able to just do. We're not going to have to break that up into pieces. Now, I'm going to leave everything under the radical for a moment, and then we'll put it out front. Okay? Let's talk about our variables. A to the 8th.
Well, that.
Can I do the fourth root of A to the 8th?
Absolutely, you can.
It's A squared.
Yes, because 8 divides by
4.
4. So A to the 8th. I don't have to break up.
Yeah, you did.
A to the 8th, I don't have to break up. I'll be able to take the fourth root. I'm doing this in my next step. If you're going to go ahead and do it now, that's fine. Now, B to the 5th. Am I going to be able to take the fourth root of B to the 5th?
Wow.
No. So go back to the same question from earlier. Closest number below 5 that divides by 4.
4.
4. So I'm going to break this up into B to the 4th. And what's my leftovers?
1 should be.
B to the 1st.
I think I got it. Sometimes I get my 6s in my B's.
Okay. Fourth root of 81 is
3.
3. That goes out front. No radical.
Oh.
Fourth root of A to the 8th.
A squared.
A squared, because 8 divided by 4 is
2.
2.
Boom.
So that A to the 2nd goes out front also. No more radical. Fourth root of B to the 4th.
Should be.
Okay.
B.
4, you're going to divide it by 4, is going to give us B to the 1st, or in other words, B. That goes out front, out of the radical. Fourth root of B to the 1st.
4, it stays in the radical.
Okay. I can't divide 1 by 4 nicely, so it's going to stay under my radical of the fourth root of B.
That looks like.
Okay? Now, I will say, one issue I remember people running into last year in Math Excel and saw this as similar, is that when you do your root, this 4 has to be like in the index here, not as an exponent to the B. So you have to be very careful there.
What?
Okay?
Oh, like it can't be. Okay.
Okay. E. We're going to look at a couple of fractions yet.
They're spicy.
Now, we can run into very easy fractions. We can run into more difficult fractions. My suggestion always when you run into a fraction is start off by asking yourself, can my fraction simplify? In other words, don't try and take any square roots, cube roots, fourth roots, whatever world you're in. Can my fraction reduce or simplify first?
No. Yes.
Yes, 16 and 3.
16. And fraction.
Okay.
What's that say?
Can fraction reduce first?
Fraction. You put it in there, Miss Sergeant, not I-O-N.
It's there. It just,
Now you're missing your eye. You drew in your eye.
it's there. Okay. So, I'm hearing this fraction can reduce. 48 divides by 3, yes? 48 divided by 3 is
16.
16. So that's going to be on top of my fraction. That's nice. What else can I reduce? Do I have x's on top and x's on bottom?
Yep.
Yeah. What x cubed on top over x to the first on bottom? Remember your rules from last week? X to the what? Second, because you subtract exponents, right? 3 minus 1 is 2. More x's on top, so we're going to put x to the second on top. Can I clean up the y's?
No.
No, but I only have y's on the bottom, right? So y to the second is going to stay on bottom. By catching the fact that we can reduce first, we just made this problem 100% easier. Because it would have gotten a lot messier if you would have tried to do square roots first. Okay. What's the square root of 16?
4.
What?
All poles on true.
What's the square root of x to the second?
X.
Because now we're back to square root world, so does 2 divide by 2?
Yeah.
2 divides by 2, and so that's x. What's the square root of y squared? Y. And 2 divided by 2 is 1 again. So y to the first on bottom.
Answer.
So I end up with,
Wait, how'd you get rid of that 3?
Because look, when you simplify, 48 divided by
3
3.
divided by 48 is, oh, okay, I see what you did.
oh,
Whenever you do to the top, you gotta do to the bottom. You know what I'm saying?
I see what you did there.
Genius. I didn't do it. Genius.
okay. So my recommendation, clean up what you can in the fraction, then talk about square roots. We good? 48 divided by 3
Wait, I see
is
what we did
16.
here. I see what we did here.
X cubed divided by x was x squared.
Yep.
Y squared just carried down to the bottom.
Hey.
Okay.
I was still in cube world.
Okay, so S. Speaking of cube world, here we go back to cube world. Now,
Now we're in your world.
we're talking about fractions again. Please listen. Can anything reduce? Now,
yeah.
number-wise, I just have 125 on the bottom. I'm not reducing that.
What about X?
I just have y's on top, but I do have x both places, don't I?
Here, so.
What is x to the fourth divided by x?
X third.
No, it's
X.
X to the 4th.
Oh, it's by. Oh, I'm stupid.
Wait a minute. Is your
I actually liked Gatlin's answer.
Oh, I did too.
Second guess yourself. If this is
Aaron called me stupid.
x to the fourth divided by x.
It's just 4 minus 1.
4 minus 1 is going to be x to the third.
You're not looking at the exponent.
I'm not doing roots yet. I'm not trying to do cube roots yet.
piece of junk?
So, what I'm trying to get you guys to do is we're going to rewrite this. X to the fourth divided by x. It's going to be x to the third on top. Y squared stays on top. 125 stays on
Oh,
in the denominator. Okay? Cube root world? Okay, can I take the cube root of x cubed?
X.
Why x?
Because it's 3. 3 divided by
3 divided by 3 is x to the first. Okay?
Oh, yeah.
Whoops. Yeah. Okay. Can I take the cube root of y squared?
Y squared.
No. 2 does not divide by 3, and it's already smaller than 3, isn't it?
Yeah.
So we're just going to leave that as
You can do 125 though.
cube root of y squared.
yeah, it's 5.
Can we do the cube root of 125?
Yeah, it's on my sheet.
5.
It's on his paper. Cube root of 125 is 5. Okay, guys. Simplifying radicals.
All right, we got it.
There's a lot of different things you have to look at. There's a lot of, different types of problems. You've got to pay attention to what world you're in. Square root, cube root, fourth root, fifth root, whatever they throw at you. Okay. The bottom part of this page, we are going to be multiplying radicals.
Oh.
Now, here's how I teach this. You can do this two different ways. I suggest that we multiply the radicals together and then simplify like we just were here. Although, and I honestly don't know what the Savas Help teaches, but the other option is you can simplify radical, then multiply them, and then simplify in the end if you need to. Have a seat. My recommendation is going to be we multiply and then simplify. Now, as I look at A, can I multiply these radicals?
Absolutely, yeah. I mean, x times 5 is x plus 5.
Okay.
Or 7.
If we look at the top of the paper, what has to be true for the radicals to be able to be multiplied?
It's gonna be equal or whatever.
Oh, well, yeah.
They have to be the same type of root, yes?
Well, they are the same root.
So, okay,
That one just has a large 3, but that's not.
okay. This is a square root times a square root,
That's true.
so we can multiply them. Now,
That's
noticing
square.
there's a 3 out front.
That's still,
That 3 out front stays out front.
that's still square root rule.
Yeah, we're not.
Okay, yeah, that 3, that's not a cube root. That 3 is just a constant 3 out front. So I'm going to keep my 3 out front. Then we're going to multiply the underneaths. 5 times 8 is
40.
40.
X to the 12.
Yeah, because you add
X.
when you multiply.
Okay,
Yeah.
x to the 5th times x to the 7th. 5 plus 7 makes it x to the 12th.
The 11.
Y to the 5th times y to the 6th. 5 plus 6 is y to the
11.
11th.
Now you can simplify. Simplify.
Okay, now we've multiplied. We've got to simplify anything we can. The 3 stays out front the whole time.
Even out there.
Square root of 40.
40. Is 40
Uh-huh.
a perfect square? Is it on my paper?
No, but 4 and 10.
Okay,
No.
so
Well, 10's not on there.
40 doesn't divide by 36, doesn't divide by 25, doesn't divide by 16, doesn't divide by 9. One thing it divides by is 4. So I'm going to rewrite 40 as 4 times 10. I picked 4 because it was a perfect square. X to the 12th.
4. X to the 4th.
And?
Or, no. 6.
Okay. Am I going to be able to take the square root when the time comes? We're in square root world, so we just have to be able to divide by 2. Just 12 divide by 2.
Yeah.
Yep.
Okay, so I'm going to just leave x to the 12th as is. Y to the 11th. Can y to the 11th be square rooted?
Nope.
No. So do you know what I'm going to ask?
10.
Closest number below 11 that does divide by 2.
10.
10. So I'm going to break this into 10 and
1.
1 is my leftover. Okay. The 3 out front stays out front.
WWE.
What's the square root of 4?
2.
2. What's the square root of 10?
5.
Square root of 10 is square root of 10. It stays under the radical. What's the square root of x to the 12th?
6.
12 divided by 2 makes it x to the 6th. What's the square root of y to the 10th? 10 divided by 2 makes it y to the 5th. What's the square root of y to the 1st? 1 does not divide by 2, so we're leaving it as y. Do clean up at the end. Don't leave it as 3 times 2. 3 times 2 is going to make this 6, x to the 6th, y to the 5th, square root of 10y. Okay. If you look, part 2, we're going to practice some more multiplying examples tomorrow, and we're going to practice some dividing, rationalizing examples tomorrow. So, lesson 5.2, part 2 homework in Savas is available, but it should not have a due date tomorrow. It should have a due date of Wednesday on it, I believe. Have a good day.
No, you.